Hello students, good evening everyone. Guys, are you getting my voice? Hello students. Good evening guys. Welcome to the physics session. Inform others to join quickly. Good evening Nana. Good evening Shubha. Good evening Ma. Inform your friends if anyone is in contact with you Nana. Inform your friends to join me quickly. Okay guys. Fine. So first few minutes, let us go ahead quickly. Let us go ahead quickly with few important points. Then we'll try to work out few questions based on interference related points or concepts, specifically calculation of amplitudes or intensity of resulting waves. Okay, right. Yes, Nana. Good evening, guys. Nithin, good evening, Nana. Good evening. Inform your friends to join quickly. Just a second, guys. Hello, sir. 18th one, sir. ఒక్క సెకండ్ సార్ చూస్తాను స్టూడెంట్స్ be in line. I will get back to you. Yes, hello students. I hope you are getting my voice clearly. Yeah, as part of the wavefront, let us see. Let us see briefly what is wavefront. So wavefront is nothing but locus of all the particles of the medium which are having same phase is called as wavefront. The wavefronts are classified into different types, specifically three types: spherical wavefront, cylindrical wavefront, and plane wavefront. Okay, the source of spherical wavefront is a point source of light, or you can also say spherical source of light as well. Whereas source of cylindrical wavefront should be a line source or cylindrical source also, you can say. So uh, what you can say, for a point source, spherical the wavefronts are, the shape of spherical wavefronts are concentric circles, whereas the cylindrical, what do you call, for a linear source, shape of the cylindrical wavefronts are coaxial cylinders. Coaxial cylinders. Similarly, like you say, plane wavefront. If you have either a spherical wavefront or cylindrical wavefront, at a distant point, if you go to the distant point, small portion, if you see here, small portion of the spherical wavefront or a cylindrical wavefront looks like a plane wavefront. So the source of plane wavefront should be small portion of spherical or cylindrical wavefront will act as a source of a plane wavefront. Okay, so this is briefly about the wavefronts and Huygens principle. In understanding the concept of these waves, we need to have an idea about Huygens principle. Huygens principle says that whenever light is propagating in the form of these waves, we come across the primary wavefronts, secondary wavefronts, etc. Primary wavefronts are nothing but at a particular distance or equidistance from a given the source. Okay, every point, the points, if you collect the locus of the points having a same phase, we call it as a wavefront. We can also call it as what do you call, primary wavefront. But every point in the primary wavefront act like source of secondary wavefronts. So this you might have visualized in water waves. If you have water in a tub, fill it with a tub, and if you have not disturbed that, it is in still position, or what you call stationary position. At that moment, if you drop a stone, it will create water ripples. Once again, if you create a stone, some water waves will what you call, they mix up, and they will give some points maximum and minimum amplitudes. And these during this observation, you can see some of the points, some smaller waves also will produce due to the mixing of the waves traveling in different directions. So it's something like, you can see, let me give you something like this. If you somewhere here, if you drop a stone, waves will be producing like this, and somewhere here again, if you drop a stone, waves will be producing like this, and due to this disturbance, again new waves will produce. Like this kind of waves can be called as what you call secondary waves, or you can say that the secondary wavelets. Secondary wavelets. This will be every point on this wave will be having same phase. Every point here on this will behave like in a source of a new wavelet or new wavelet. We can call them as secondary wavelets. Okay, secondary wavelets. Okay, now just as part of this, we need to just have an idea about these waves. They may undergo refraction and reflection also. So if the waves, just like when light travels in ray optics, I have discussed about refraction and reflection of light, right? But when we have dealt this light as in the time in the form of rays, but if you treat it as a wave, this entire wave, when it falls on a surface, it will refract. When it refracts, we are not dealing this in detail, so we can just say that it obeys the same laws of diffraction which you have used during the study of what you call Snell's law. Snell's law can be applicable here also when you apply the waves. So wave can diffract and wave can reflect also. That can be explained with the help of Huygens wave theory. So that particular part we are not going into the details now here. Here our main concept of interest is how to understand the interference of waves, and how to understand further what you call constructive and destructive interferences. So for that purpose, we have this. Let us consider wave equation. Wave equation. When you consider light as a wave, you can represent wave as y is equal to displacement of the wave as y is equal to a sin omega t plus y naught, where y represents the displacement of the particle of the medium. When light is moving in a particle, just like water waves, water ripples are propagating in liquid medium. So light waves are usually when they're moving in medium, just they usually in olden days, actually when Huygens has proposed his theory, they used to believe that light needs a medium. They used to believe that there is a medium called ether medium. is a low dense medium like that they have introduced, but later it was proved that there is no such medium like ether medium. Okay, an experiment called Foucault's experiment has proved that there is no medium. Okay, and so usually what electromagnetic, this are treated as electromagnetic waves. Later Maxwell's electromagnetic theory has proved that here for particles like what you call we can say that this will electric and magnetic fields will vibrate perpendicular to the direction of propagation of light. So in that form they have what you call explain this same thing by using wave relation only, wave representation only. So here if y is representing displacement of a wave, light wave, then it can be expressed as y equal to a sin omega t plus y naught, where a is amplitude of that wave, omega is angular frequency or angular velocity, and t is the time. At a given time, what is the amplitude displacement? You can calculate, you can consider accordingly. Where phi naught will be taken as this omega t plus phi naught together will be called as phase or phase angular total phase of the given wave. Where phi naught can be called as initial phase or epoch. Initial phase or epoch. That means at time t equal to 0. Initial phase at time t equal to 0. That is phase at time t equal to 0. Phase at time t equal to 0 is called initial phase. Something happened to this. It is not activating properly. What happened? Let me just close this file and open. Something happened to this file. It's not responding properly. Right. Yeah. See here where we are. Yeah. Where phi naught is initial phase or epoch. That means phase at t equal to 0 is called initial phase. Phase at time t equal to 0 is called initial phase. Phase at time t equal to 0 is called initial phase. Okay. Right. So these are few parameters in this expression. Now here we are can here this is in terms of angle, phase angle. Okay, usually this kind of representation of wave, light wave can be used when you are dealing and when you are especially any wave, sound wave or light waves can be expressed in this form. When you are dealing with the vibrational motion or simple harmonic motion, we will use these equations. Sometimes we use this also. How we'll see in a few seconds. Another representation is in terms of propagation. How can you express this light wave or any wave? We can call it as progressive wave. If you are treating light as a progressive wave, you can express the displacement of the light wave as y is equal to a sin omega t plus or minus kx, where all parameters have this same meaning, except here we have come across this new term called kx, where k is called as wave number. It is denoted by 2 pi by lambda, where lambda is wavelength. Okay, and other terms have same meaning. If the wave is propagating in positive x direction, we have to write it as omega t minus kx. If it is moving in negative x direction, we will take it as omega t plus kx. Okay, but we are not going to the details of those now, right now. But as an idea, brief idea, I am giving you these points. Now, let us try to discuss about the superposition of coherent waves or light waves. Anyway, two waves. If we consider two waves which are represented with the displacements of those two waves are represented as y1 and y2, which are given by y1 equal to a1 sin omega t plus y1, and y2 is a2 in sin omega t plus y2. That means they are having different amplitudes. If you consider two waves of slightly different amplitudes and same angular frequency or same angular velocity, and initial phases are different, then after some time, if they meet at some point, then they will meet together. They will superpose. Superposition is nothing but the meeting of the waves or mixing of the waves. So when they mix up, then you will get a resultant wave. That formation of resultant wave when two waves meet at a point is called a superposition of waves. So that superposition of waves gives a resultant wave. The resultant wave is given by vector sum of the individual waves or superposing waves or interfering waves. You can call it as superposition or interference. So the displacement here y can be called as displacement of the resultant wave, and y1, y2 are called as displacements of the individual interfering waves or superposing waves. So by substituting this over here and on simplifying, we get this here. This is in the form of sin a plus b. This is also in sin a plus b form. If you expand this, sin a cos b plus cos a sin b, this is also in the same form. And if you take sin omega t terms out sin omega t here, sin omega t here, then we'll get a1 cos phi 1 plus a2 cos phi 2. Similarly, cos omega t term and cos omega t term, if we take out, then we'll get a1 sin phi 1 plus a2 sin phi 2. Here, these terms will be taken as a constant terms, as phi phase. For a given phase, we take them as constant terms. We can write it as a cos phi into sin omega t. Similarly, here this you can replace with a this a sin phi, this is replaced with a sin phi, this is replaced with a cos phi here, and this cos omega t as it is, we will take as it is. Now this can be written as, by a is common here, if you take it out you can write it as sin omega t cos phi plus cos omega t sin phi. It is also in the form of sin a plus b, so then we can rewrite this as a sin omega t plus phi. This gives you the resultant displacement of the resulting wave, resultant displacement of the resulting wave. So here now you can write here how you have taken this cos a cos phi and a sin phi. Here a cos phi is taken as this sum of these two terms, and a sin phi is taken as sum of these two terms, is replaced with a sin phi. If you take this as equations 1 and 2, then you can get what do you call amplitude. Here this gives you displacement of the resulting wave, and this a will be called as amplitude of the resultant wave, and this is called as what do you call total phase angle of the resulting wave. Phi is called initial phase of the resulting wave. Omega is angular frequency of resulting wave, like that you can call it. So amplitude of the resulting wave, if you want, you have to square and add these two equations. So for 1 square plus 2 square gives you a square cos square phi plus a square sin square phi. As a square is common, if you take it out, sin square phi plus cos square phi gives you 1. So that step I have skipped here. So you will get a square into 1, that is a square is equal to these terms. If you square and simplify, again that's a simplification part I have skipped here. Directly can say again here a1 square cos square phi 1 plus a1 square sin square phi 1. Here a1 square, if you take out, cos square phi 1 plus sin square phi 1 give you 1. Similarly, like here for a2 square also you get a2 square plus 2ab form. If you expand, then the final result will come here as cos a cos b plus sin a sin b form. That will give you as cos a minus b. If you take it as cos a minus b here, then you will get cos phi 1 minus cos phi 2 form. Okay. This can be further expressed as a is equal to square root of, if you take this phi 1 minus phi 2 as phi, which is as phase difference, you can write it as a is equal to a square root of a1 square plus a2 square plus 2a1 a2 cos phi, where phi is phase difference of individual waves, phase difference between the individual waves. Okay, so this you have to keep in mind while doing the numericals. So now here, so we can say this gives you what amplitude of the resulting wave, resultant wave or resulting wave. So by making use of this, you can also try to find the intensity of resultant wave. Intensity of resultant wave, it is given by to find the here itself. If you want to find the phase of the resultant wave, so from these two equations, if you divide this second equation by first equation, you get this one, tan phi is equal to this. We say this gives you phase of the resultant wave. Whereas if you want the intensity of resultant wave, as intensity is, as we know that intensity is directly proportional to amplitude square, you can write intensity of the amplitude of resultant wave is this. And if you want to write in terms of square of amplitude, you can write it as a square. Equation 3 can be expressed as a square is equal to a1 square plus a2 square plus 2a1 a2 cos phi. This if you want to write in terms of intensities, because amplitude square is equal to intensity. Amplitude of resultant wave can be taken as intensity of resultant wave. Amplitude of the first wave can be taken as intensity of the first wave, and amplitude of square of the amplitude of the second wave can be taken as intensity of second wave. Like that, if you take square of amplitude of first wave is intensity of first wave, whereas amplitude of first wave is square root of intensity. Similarly, a2 square is I2 means a2 will be square root of a2 I2. So if you substitute this over here, then you can get intensity of the resulting wave is equal to I is equal to I1 plus I2 plus 2 into a1 a2 as are root I1 into root I2 into cos phi. This further can be expressed this way. This gives the, you can write down here, this gives this gives the intensity of resulting wave. resulting wave. Okay, so here we'll discuss few special cases, guys. This intensity will be maximum, not only intensity. Equation 3 gives you a resulting amplitude. Equation 3 gives us resulting amplitude or amplitude of the resultant wave, and here equation 5 gives intensity of the resulting wave. If you observe these two equations, intensity of the resultant wave and amplitude of the resultant wave depends on this phi, the term phi, where phi is called phase difference or phase of the resulting wave. So here this intensity will be maximum if cos value is maximum. Maximum value of cos will be +1, and the cos value will be oscillating between +1 and -1. Cos value, if you observe the cos graph, cosine graph, cos graph can be given like this. Cos graph will oscillating between +1 and -1. Okay, maximum value of cos will be +1, minimum value will be -1. If cos is +1, then the intensity will be maximum. If cos is -1, then the intensity will be minimum. So the condition which is giving maximum intensity and hence maximum amplitude will be called as constructive interference. If you are when you will get maximum intensity when the amplitude is maximum, when you will get maximum amplitude is, so if you see this is amplitude of the resulting wave. If you consider here, you can say the special cases. Under this, write down first case constructive interference. Constructive interference. So if two waves, if one wave, like if you are coming across a wave like this is one wave, right, and another wave just at this point. So something like this to understand this little simplest form. If you are having at this point, if a wave is coming here and meeting, another wave is coming here and meeting, so that this actually here you can see if a trough is going to start here, this can called as crest and trough. So that if a wave is traveling and there at this point another wave is coming, and so here the crest only, if it meets, this crest and crest will meet up, and this crest of first one, crest of second one will meet, and it will get the larger crest value or maximum amplitude of this, and amplitude of this will combine and we will get maximum amplitude. To get this maximum amplitude and hence maximum intensity, these two waves should interfere in such a way that that kind of interference will be called as constructive interference. So conditions for constructive interference will be such that amplitude should be maximum for that. So what you can say in this case is, as part of the case 1, or you can call it as constructive interference, we consider the phase angle will be taken as phase angle. What is the phase difference or phase angle? Phase difference, you can say in phase difference phi will be, if you observe both amplitude and intensity, as A is equal to square root of A1 square plus A2 square plus 2A1 A2 into cos phi, and intensity is I is equal to I1 plus I2 plus 2 into square root of I1 I2 into cos phi. If cos value is maximum, amplitude and hence intensity will be maximum. So when what will be the maximum value of cos? So for constructive interference, you can say for constructive interference, cos phi should be equal to +1 or plus or minus +1. Cos phi value should be equal to +1. For what angles of cos we get +1? For cos that implies phi will be equal to 0. Cos 0 is 1, and for what another angle cos can be +1, you know, this is a cos wave. Right? So if you consider this is one wave of cos, this is another wave. For cos 0 you will get 1, then cos 2 pi you will get 1, then again cos 4 pi you will get 1. So like this for multiples of 2 pi. So you can say if it can be 0 for 0, 2 pi, 4 pi, and all this kind of integral, what is called even integral multiples of pi, will get maximum value, and hence amplitude will be maximum and also intensity will be maximum. That means you can say for phi is equal to 2 into n into pi. N can be 0, 1, 2, 3 and so on. So that n can be equal to 0, 1, 2, 3 and so on. If n is 0, pi will be 0. If n is 1, 2 pi. 2 into 2, 4 pi. 3, 6 pi, like that. For all in even multiples of pi, you will get cos phi as plus 1, and hence amplitude and hence intensity will be maximum. So if you substitute these values, say for example, if you take it as if you take this cos phi as 1 plus 1, then what will you get? If this is 1 means we will get maximum amplitude. So this implies a maximum is equal to square root of a1 square plus a2 square plus 2a1 a2 will get. So it is in the form of a square plus b square plus 2ab form. So it can write it as a plus b whole square form. A1 plus a1 square plus a2 square plus 2a1 a2 can be expressed as a1 square plus a2 square plus 2a1 a2. This further can be expressed as square root of a1 plus a2 whole square. This gives you a1 plus a2. So you can say maximum value of amplitude under constructive interference is a1 plus a2. Okay, whereas similarly, when cos phi is maximum, we'll get maximum intensity. So what will be the corresponding maximum intensity? You can say I maximum is equal to, when cos phi is 1, so then you can write it as I1 plus I2 plus 2 into root I1 into root I2. Okay, so that means you can express this in the form of I1, what is that? Root I1 square plus root I2 square plus 2 into root I1 into root I2. It is in the form of a plus b whole square form only, can write. So that is square root of I1 plus square root of I2 whole square. Got it? So it is A1 should be root I1, A2 should be root I2. Whole square will give you maximum intensity. So this gives you maximum intensity relation. Maximum amplitude and maximum intensity. Did you understand now how to get this? So this gives you maximum amplitude and maximum intensity under an interference called constructive interference. Constructive interference. Now let us see the special second case, special case 2. Case 2. So that is destructive interference. Destructive interference. Destructive interference. So for destructive interference, what does a constructive interference means? The interference where we get maximum amplitude will be called as constructive interference. Constructively they should meet. But destructive interference means the interference where the resultant amplitude will become minimum possible. Minimum possible, that kind of interference will be called as destructive interference. When it can be possible here, so instead of here the crust and the crust of this, here when this comes, when the crust is starting, here also you have to say when crust is supposed to start, here you have to just understand this little carefully. When this, if you consider this crust and crust combines, then it will give you maximum amplitude. Whereas if there is a trough, this trough and this trough will join, you get minimum or zero amplitude. So to get that kind of interference is called the interference where the resulting amplitude is minimum. Resulting amplitude is minimum will be called as destructive interference. It's called as destructive interference. So if you want, you can write the definition also. So for destructive interference, amplitude and hence intensity will be minimum. From this expressions, this is actually third equation, this is fifth equation, right? This third and this is fifth one. When this amplitude can be minimum, when cos value is minimum. For what is the minimum value of cos? -1. So you can say for destructive interference, for a destructive interference, cos phi value will be equal to -1. That means phi value, for what value of phi? Again, if you observe the cos waveform, this is cos waveform, right? So for 0, 2 pi, 4 pi and all, it will get +1. For what values of cos will get -1? This is -1, right? Cos 0, 90, 180. For cos 180 will get -1, means for pi. 180 means what? Pi. So for pi, then again 2 pi is plus 1, then 3 pi, 3 pi, then 4 pi is plus 1, then 5 pi. So that means odd multiples of pi values will give you minus 1. So this can be expressed as that means phi should be equal to 2n minus 1 into pi you can take. That means if n is equal to 0, 2 into 0 you have to take, if you take 2n minus 1, you have to take n equal to 1 2 3 and so on. If it is 2n plus 1, if you take, then n can be taken as what you call 0 1 2 3 and so on. That is how you have to remember. And now if you take plus 1, then again n can take 0 1 2 3 and so on. If n is 0, then this 2 into 0 is 0, pi you will get. N is 1, 2 into 1, 2 plus 1, 3. So 3 pi, pi, 3 pi, 5 pi, like that you will get. So for these values of pi, you will get destructive. For these values of phi, phase difference, you will get destructive interference. So we can call it as phase difference will be, values for destructive interference will be, or what you call phase condition for destructive interference is 2n, pi, 2n plus 1 into phi. So if you substitute this, what kind of expressions will get for constructive and destructive interference? Let us see. If cos phi value is minus 1, then maximum amplitude, resulting amplitude will be given by square root of a1 square plus a2 square plus 2a1 a2 into cos phi. Cos phi is minus 1, means you will get minus 2a1 a2. So this will be in the form of a square plus b square minus 2ab form. So then you can write this as square root of a minus b whole square. So you will get a1 minus a2. This will give you minimum intensity. This will give you minimum intensity. This will give you minimum amplitude. This will give you minimum amplitude. Corresponding minimum intensity is given by I minimum is given by when cos phi is minus 1. This cos phi is minus 1. This can be expressed as in terms of root I1 whole square plus root I2 whole square plus here minus 2 into root I1 root I2. So this can be expressed as root I1 minus root I2 whole square will get. This will be actually a1 minus a2 whole square under root gives you this. This is root I1 minus root I2 whole square will give you minimum intensity. Minimum intensity. So this is how we will get the expressions for maximum and minimum. Maximum intensity will be root I1 plus root I2 whole square. Minimum intensity will be root I1 minus root I2 whole square. Maximum amplitude under constructive interference is A1 plus A2. Minimum amplitude under destructive interference is A1 minus A2. Okay. So these are the few expressions you have to keep in mind, guys. Okay. Copy these points quickly. So phase difference conditions for constructive and destructive interference. Once again, we will discuss all these points, including one more point called path difference, while discussing the YDSE Young's double slit experiment. So based on these points, let us try to work out few questions, guys. Now let us try to understand few questions. Before going ahead with the questions, here you can also note down one relation here. You can say those equations are till 5 we have discussed it, right? So this maximum amplitude can be taken as equation 6, maximum intensity can take it as equation 7, and minimum amplitude can be taken as equation 8, and minimum intensity can be taken as equation 9. So from this, sometimes you may get the questions like, if by giving the amplitude wave equations, you may ask to find the ratio of maximum and minimum amplitudes, a ratio of maximum and minimum intensities. So for that you can use these relations. So you can also say from this, from 6, 7, 8 and 9, we can say ratio of maximum and minimum intensities. I maximum by I minimum can be expressed as I maximum is square root of I1 plus square root of I2 whole square divided by I minimum is square root of I1 minus square root of I2 whole square. Okay, whereas this can also be expressed as what is this? Actually, intensity is directly proportional to square of amplitude, right? Square of amplitude, or you can also say root I1 can be expressed as A1. So this can be expressed as in terms of amplitudes as A1 plus root I2 can be expressed as A2 whole square. Similarly, this can be expressed as A1 minus A2 whole square also you can express. So while doing the numericals, we may make use of these relations. We have to keep this in mind. Now let us go ahead with some questions. Open level 1 exercise 1 questions. In level 2, this kind of questions based on this questions are not given. In level 1 they are given. So let us try to work out some questions from level 1 exercise 1. Level 1 exercise 1. Right. Level 1 exercise 1. So question number 1, page number 225. Open 225, page number 225 guys. Based on interference, try to work out quickly few questions. So question number 1. And one more point just I would like to stress here that YDSC part will especially the basic points on about YDSC only is there for this weekend, and the detailed part fringe width calculations etc is not there for this week. Next week will be having. So with this your this weekend portion will be completed. You can practice the questions based on this. So we have completed the portion guys. Keep that in mind and practice more questions based on this. Right now, so question 1, what is given here is, let me read the question once. So if you want you can write the question. If anyone is interested to write copy the question. The question is, the displacements of two interfering light waves are y1 is equal to 4 sin omega t and y2 is equal to 3 cos omega t, full stop. The amplitude of the resultant wave is the amplitude of resultant wave is the question. Amplitude of resultant wave we are asked to find, and it is also mentioned that here y1 y2 are in CGS system, means displacements are in CGS system and hence amplitudes also are in CGS system. That is the meaning of it. Okay, the condition is where y1 and y2 are in CGS system. This is the question. So how to find, and what you are asked to find? Amplitude of the resultant wave. Amplitude of the resultant wave is what? And we know that amplitude of resultant wave, amplitude of resultant wave is A is equal to square root of A1 square plus A2 square plus 2 A1 A2 cos phi. Phi is phase difference between the two waves. Okay, so here A1 is 4, A2 is 3. What is phase difference? If both are in sine functions, phase difference will be 0. But this is a sine, this is cos. Obviously that means one is sine, another is cos, means you have to say the phase difference between them will be pi by 2. Okay, how can you say that is? Cos theta can be expressed as, cos theta can be taken as sine 90 minus theta. 90 minus theta. So or can you say that what if say it is, this is you can say that yes, so you can take this as sin omega t as cos 90 minus theta, or cos omega t as sin 90 minus theta also can take it as. So to get in the same either sin form or cos form, if you have to take it as a sin 90 minus omega t form, that means the phase difference between them should be 90 degrees. The other way you can, if you want to understand how to understand the phase difference between this is, this is sine wave and this is cos wave. This is cos wave. This is one full wave. Okay. So here you can say sine 0 is, this is sine 0 is 0, cos 0 is 1, cos 0 is 1. So and if you observe the what you call values, sin theta and cos theta values, sin theta and cos theta values, for to obtain the same value, say for example same phase value, or say for example 1 1, sin 90 will be 1, whereas cos 0 will be 1. That angle cos 0 angle, if you want to make it as 90, you have to add 90 degrees. That way also can understand the phase difference, how they are vibrating. So to understand this, just I have given a simple example, you can analyze and understand this. So phase difference between this cos and sine will be 90 degrees, so I have to take this as phi is 90. So cos 90 will be, if phi is pi by 2 radians or 90 degrees, and hence cos 90 degrees will be equal to 0. If cos phi is 0 means this entire term becomes 0. So then resultant amplitude becomes square root of a1 square plus a2 square. a1 is 4 square plus a2 is 3 square. So it is 4 square is 16 plus 3 square is 9. Square root of 25 will get, it is equal to 5. It is in centimeters. So resultant amplitude is nothing but 5 centimeters. The amplitude of the resulting wave is 5 centimeters. Amplitude of resultant wave is 5 centimeters. Is that clear, everyone? So options, if you want, you can choose the corresponding options. Similarly, let us go ahead with the next question. Question number 2. It is given that two coherent sources of different intensities send waves that interfere. The ratio of maximum to minimum intensity is, maximum to minimum intensities, that means I maximum by I minimum is 25. The intensity ratio of the sources are, that means intensity of the first source, if it is I1, and of the second one is I2, what is the ratio of this is the question. I am reading the question once again. If you want, you can copy carefully. So the question is, two coherent sources of different intensities send waves that interfere. The ratio of maximum to minimum intensity is 25. The intensity ratio of sources is, options, just I don't want to give the options, you can calculate this anyway. Okay. If you want the options, of course you can note down the options. First option is 25 is to 1, and second option is 5 is to 1, third option is 9 is to 4, and fourth option is 625 is to 1. Yes, how to find this? By knowing this, how to find I1 by I2? Yes, we can try, because we know I maximum is nothing but, we know that I maximum by I minimum is equal to, I maximum is nothing but square root of I1 plus square root of I2 whole square divided by square root of I1 minus square root of I2 whole square. This is I maximum, this is I minimum. Ratio of these two can be also expressed as this. This is equal to 25, means 25 by 1. This further you can simplify, and you can write it as, what is this is, if you send this square this side, you can get, you can also write this as, this implies square root of I1 plus square root of I2 is equal to, or square root of I1 plus I2 root I2 by square root of I1 minus square root of I2 is equal to root 25 by 1 can be expressed as 5 by 1. Yes, then what we are asked to find, I1 by I2 or something else? Second question, we are asked to find ratio of the intensity ratio of the sources. Intensity ratio of the sources. What is I1 by I2? So simplify this. How can you get this? I1, root I1 plus root I2 is equal to 5 into root I1 minus 5 into root I2. Okay, and if you bring this one side, what you can write, root I1 plus root I2 is equal to 5 into root I1 minus 5 into root I2. Okay, so This is I1 term. This is also I1 term. Bring one side I1 terms and I2 terms other side. If you bring here 5 root I1 minus root I1 gives you 4. What do you call 4 root I1, and if you send this side, this one this side, minus 5 will become plus, so 5 plus 1 6, you get 6 root what I2. We are asked to find I1 by I2, right? So that means let us bring this I2 here and send that number that side, then we will get root I1 by root I2 is equal to 6 by 4, 6 by 4, right? And this, if you simplify further, you will get 2 3s, 2 2s, 3 by 2. Because you want I1 by I2, if you square on both sides, we will get I1 by I2 is equal to 9 by 4. That's it. That's it. This implies on squaring we will get 9 by 4, or 9 is to 4. 9 is to 4. So options, if you observe, 9 is to 4 is given in third option. That is the right one. Got it? Next. Question number, similarly, you can work out question number 3. Question number 3. So what is given here? Two sources of intensity 2i and 8i are used in an interference experiment. The intensity at a point where waves from two sources superpose with a phase difference of 0 and phase difference of pi by 2 and with a phase difference of pi is the intensity, the resultant intensity is what? When the phase difference are this. So I am reading the question once again, try to write down if you want. Two sources of intensity 2i and 8i are used in an interference experiment. Full stop. The intensity at a point where the waves from two sources superpose with a phase difference of number 1 0, number 2 pi by 2, number 3 pi is. So options are given as 18i, 10i, 2i. Second option is given as 5i, 4i, I. Third option is given as 2i, I by 2. Fourth option is given as 2i, 10i and 18i. So I hope you have understood the question. I am giving you the data. What is given here is, if two sources of intensities are given, that means I1 is equal to 2i and I2 is equal to 8i, then intensity at a point, that means the resultant intensity is what? At when phase difference is equal to 0, and second case when phase difference is equal to pi by 2, and in the third case when phase difference phi is equal to pi, when phi is 0, what is I? Resultant intensity. Pi by 2, what is resultant intensity? When phi is pi, what is resultant intensity is the question. So to find this, you have to recollect back the expression for resultant intensity. I is equal to square root of I1 plus, I1 plus, not square root of I1. So it is equal to, I is equal to I1 plus I2 plus, we know that resultant intensity is I1 plus I2 plus 2 into square root of I1 into I2 into cos phi. So for first case, theta phi is equal to 0, I is equal to what? So I1 is 2i, I2 is 8i, 2i plus 8i is 10i plus 2 into cos 0 is 1. So root of I1 I2, I1 is 2i, I2 is 8i. So square root of 2 into 8 is 16 I square under root into cos 0. Cos 0 is 1. So we'll get 16 root is 8 and I square root is I. So 8 into 2, 16. 10 plus 16. 10 plus 16 is 26 I. Right? This will be I in first case. How much? How much? Is it 10 plus 16 or root 16 is 4, right? I did a small mistake, guys. Root 16 is 4. 4 into 2 is 8. So 10 plus 8 is 18. 18 I will get. So this will be the resultant intensity in first case. Resultant intensity in first case. 89. So obviously once you get this, if you come across only one option is having the first intensity is 89, you can directly tick that. Otherwise, if you want little more clarity, you have to take the second case also. If phase difference phi is equal to phi is pi by 2, then intensity is here. If phi is pi by 2, cos pi by 2 will be 0, cos 90 is 0, this entire term becomes 0, then it will get intensity is nothing but I1 plus I2. I1 plus I2 is nothing but 10I. That's it. So obviously that's first option itself is the correct one. You can say 18I and 10I is given in first option. So if you want, you can cross check again for third one. When phi is equal to pi cos what is this? Then I is equal to cos 180 is minus 1. So this is minus into this. So you can write it as I1 plus I2 is 10I minus minus 8I. 10I minus 8I is 2I. So we'll get 10I minus 8I gives you 2I. So these are the corresponding values. I hope you have understood this. I hope you have understood how to do this. Next, question number 4. Question number 4. Let's see. It is given that. Let me read the question once. If you want, you can copy it. The question is: the intensity of interference waves in an interference pattern is same as I naught. The resultant intensity at the point of observation will be. Options are given. First option is I is equal to 2 I naught into 1 plus cos phi. Second option is given as I is equal to I naught into 1 plus cos phi, and third option is given as I is equal to 1 plus cos phi divided by I naught. Fourth option is given as I is equal to 1 plus cos phi by 2 I naught. So which option is right? So if you observe the question once again, it is given that the intensity of interference waves in an interference pattern is the same as I naught. Intensity of interference waves means what is that? Interference waves intensity is first intensity can be I1 and second one can be expressed as I2. They are equal to I naught. That is the meaning of it. Intensity of interference waves in an interference experiment is same as I naught. That means equal to I naught. Both are equal to I naught. Then the resultant intensity at the point of observation is what is I is the question. So we know that I is equal to I1 plus I2 plus 2 into square root of I1 into I2 into cos phi. So if you substitute these values, it is equal to I1 is I naught, I2 is I naught, plus 2 into square root of I naught into I naught is I naught square into cos phi. Phi value is not given. Let us take this as it is. Okay, it is equal to I naught plus I naught square is I naught. 2 I naught plus 2 I naught is how much? Sorry, you cannot do that. So you have to write this as I naught plus I naught is 2 I naught plus this becomes 2 I naught into cos phi. Can you take it as 4 I naught into cos phi? No, this is a separate, this itself is a separate term. This entire thing is one term. So here 2 I naught is common. So you can write this as by taking 2 I naught common, you can write it as 2 I naught into 1 plus cos phi will be the resultant intensity at a given point. I hope it is clear for you guys. That's it. This is the final answer for this question. Okay. These are 3 questions based on interference of waves and how to find the intensity. Whereas in level 1 exercise 2, few more similar kind of questions I have given. You can try to find, you can try to work out this also. You can try to work out this. So let us see here. Next, question number 1, page number 228. Question number 1, page number 228. Let me read the question once. The question is the question is the displacement of two interfering light waves are y1 is equal to 2 sin omega t and y2 is equal to 5 sin omega t plus pi by 3. Then the resultant amplitude is the question. So you can write down the question carefully and note down the options also. First option says 39 centimeters. Second option says root 39 centimeters. Third option says 7 centimeters. And fourth option says square root of 29 centimeters. So resultant amplitude. We know that resultant amplitude is resultant amplitude is A is equal to square root of A1 square plus A2 square plus 2 A1 A2 into cos phi, phase difference between the individual waves. A1 is this, A2 is this. What is cos phi? Phase difference between both are sine only. So in such case, what is this? If there is no this term, we have to take it as 0. If it is 2 sin omega t, this is 5 sin omega t, then phase difference will be 0. But here, phase difference means this is phi 1, this is phi 2. So the difference between this minus this is omega t plus pi by 3 minus omega t gives you pi by 3. Phase difference is pi by 3. Pi by 3 means 60 degrees. So cos 60 is 1 by 2. So 1 by 2 if we take, then substitute the values. What you will get? Let us see. Square root of a1 square is 2 square plus a2 square is 5 square plus 2 into a1 is 2, a2 is 5 into cos 60 is 1 by 2. So here 2 gets cancelled. 1 2 gets cancelled. Then what happens? What it gives you? Square root of 2 square is 4, 5 square is 25 plus 2 into 5 is 10. So how much you will get? This is 35 plus 4 39, square root of 39. So resultant amplitude should be equal to A should be equal to square root of 39. This is the answer. Is it clear everyone? Square root of 39. So which option is right? Second option. Similarly, you can practice few more questions guys here. So question number 2. Okay, there are just one more question is given. The other questions are given based on X double slit experiment. So just I will work out these two quickly and I will wind up. So question number 2, it is given that the intensity ratio of two waves is 9:1. Stop. If they produce interference, the ratio of maximum to minimum intensity will be. So what is given here? The intensity ratio of two waves, that is I1 by I2 is equal to 9:1. 9:1 means 9 by 1. Then if they produce interference, the ratio of maximum to minimum intensity, I maximum to I minimum, is equal to what? Is the question. Options are, first option is 4:1, second option is 2:1, third option is 9:1, fourth option is 3:2. Right. So which option is right? So we know that I maximum by I minimum is equal to, I maximum is square root of I1 plus square root of I2 whole square divided by I minimum is square root of I1 minus square root of I2 whole square. It is equal to I1, square root of I1 is 9, root 9 plus I2 is, actually speaking, you cannot take I1 as this thing. Okay, so but ratio you have to take. So otherwise you can take here I1 is equal to 9I2. This way you have to take it. Individual values are not given, so you have to take little carefully this. Okay, so how can you take this? It is equal to I1. If you cross multiply this, you can take I1 equal to 9I2. So 9I2. So square root of 9I2 plus root I2. Okay, so divided by, this is you can also say divided by, let us say whole square, right? Whole square divided by square root of I1 is 9I2, right? 9I2 minus square root of I2 whole square is equal to root 9 is 3. 3 into root I2 plus root I2 becomes what? 4 into root I2 whole square divided by that is 3 root I2 minus root I2. 3 root I2 minus I2 is 2 into root I2. Got it? Whole square. So this gives you what? Here if you take whole square for both terms common, root 2 gets cancelled, then you will get 4 by 2 whole square. So 2 gets 2 2's it gets cancelled, then you will get 2 square is 4. So it will get 4. So I maximum by I minimum is equal to 4, means 4 by 1 or 4 is to 1. I hope it is clear for you guys. Second question, option is that first one is the right one. Okay, similarly you guys try the next question as well. As time up, I'm winding the session now. Okay, so as I said, so for this weekend, this till here try to be thorough. Okay, let us meet again in the next session guys. Okay, then take care everyone, bye bye. I'm winding the session, take care, bye bye.